Hello friends, welcome to the next problem, number 9 of the Turing machine. If you observe the question now, the question over here says we are interested in finding the subtraction of two numbers, and the data type of the numbers over here is purely unary. Now we know what is unary number system. Any number which is represented only by using the number 0 is said to be unary in nature. For example, 0 will be represented by epsilon, 1 would be represented by a single 0, 2 will be represented by 2 zeros, 3 will be represented by 3 zeros, so on and so forth. So let's get started with the problem. So friends, the question over here says, on the tape in the input I'll be having in between lot of blanks 0 raised to m, 1, 0 raised to n, where it is specifically said that m minus n is going to be the one which will be assigned to p, right? So p is basically going to be the subtraction of m minus n. What I mean to say by that is, over here I would say there are three possible cases of m and n. What I mean by that is, either my m could be greater than n, or my m could be lesser than n, or my m could be equal to n. Now let's say if I'm considering the first case where my m is greater than n, let me consider m's value as 5 and n's value as 2. What I mean by that is, if m's value is considered as 5, the input is going to consist of 0 raised to 5, that is the number is going to be 5 zeros. In between as a separator we have 1, followed by 0 raised to n, n's value is 2, that signifies we'll be having 2 zeros over here. Now we are interested over here in subtraction of 5 minus 2. So we know the answer over here which is expected is going to be 3. Fine. Similarly, when I say m equal to n, let me consider m's value as 2. So n's value will also turn out to be 2. And that makes the number as 0, 0, 1, 0, 0, blank. That is the case where m is going to be equal to 2. So let me modify this. Instead of writing m less than n, let this be considered as m equal to n. So over here, if it is m less than n, let m be 2 and n be 5, the vice versa case. So we have over here blank, 2 zeros over here, 1 in between, followed by 5 zeros and a blank. Let's see how can we solve this problem. Now to look upon the logic, what am I going to do is, I'll be converting each of the zeros on the left hand side of 1 and on the right hand side of 1 and keep on replacing it by blank. I'll explain you what I mean by that. We are going to start from blank, and after this when I come across a 0, I'm going to convert this first 0 to a blank, and bypassing everything I'm going to the extreme right until I get the first blank. I will keep the blank as blank and take a U-turn. Now when I take a U-turn, the moment I get a 0, I'm going to convert it again to blank, and now bypassing everything I'm going to keep on moving to the left till I get the first blank. So first blank would be the one which I have just marked with the help of black ink. So the moment I get a blank on the leftmost side, I'll be keeping it as blank and taking a U-turn. And next time now when I get a 0, I will get it converted to blank once again, bypass everything and move to the right till I get the first blank, keep the blank as it is and take a U-turn, and to the left of this blank, if I get a 0, I will convert this to blank. Now friends, as per the logic, we are now going to bypass everything and keep on moving to the left till we get the first blank, and the moment you get the first blank, you keep it as blank and take a right turn. Now we all know that when I say m is greater than n and we are interested in subtraction of 5 minus 2, the output on the tape has to be 3. What do we mean by 3? The output has to be precisely 3 zeros which are left on the tape. So now I do see that there are 3 zeros, but the machine is going to behave in the way it is trained. So the same loop is going to execute now, and to the right of the blank, the moment I get a 0, I'll be converting it to blank, and I will move to the right bypassing everything till I get blank on the rightmost side. The moment I get a blank on the rightmost side, I'll keep it as blank and take a left turn. Now when I take a left turn, that is the time I realize that there are no zeros left. So till now we are getting a 0 over here, 0 over here, 0 over here, 0 here, and we were continuously making all of those zeros as blank. But now we got a 0 on the left hand side, but unfortunately when we came from the right hand side, we did not get a 0. That signifies that the m and n's relationship is such that m is greater than n. Now since we want output of the tape to be 3, and we see that on the tape there are only 2 zeros left, what am I going to do is I'll be converting this one to 0, and I'm going to say go to the final state. As simple as that. Okay, so that clearly signifies that I have got the output as 3 zeros. Similarly, let us consider the example of m less than n. In that case, initially we will be converting this to blank, going to the extreme end, taking a U-turn, converting this to blank, going to the extreme end, taking a U-turn, converting this to blank, going to the extreme end, taking a U-turn, converting this to blank, again going to the extreme end and taking a U-turn. So now over here when you take a U-turn, you were expecting a 0 but you got a 1. Now friends, over here m less than n scenario, you tell me what is going to be the subtraction of 2 minus 5? As per the rule of mathematics, minus 3. But we are dealing with unary numbers, and unary numbers simply say 0 would be represented by epsilon, 1 would be represented by 0, 2 would be represented by 2 zeros, 3 would be represented by 3 zeros, so on and so forth on both the cases. Unary numbers are non-negative in nature. So 2 minus 5 answer is never going to turn out to minus 3. So what are we going to do in that case? If that is the case, we are going to say the output does not exist. So what are we going to do is, the moment I get this kind of case, we understand that m is less than n. So on the state to the right of this, if you are not getting a 0, then we are going to convert this one to blank and remaining all of the zeros to blank unless and until we reach the blank, and we are going to stop. So in this case 2 minus 5 over here is going to be blank for me, because negative number result cannot be given as output for the subtraction of unary numbers, right? As of now, just understand the logic. When we go to the implementation part, we will see how the implementation diagram is going to function. Next, the last example where m is equal to n, where m is 2 and n is also 2. So you make this as blank, go to the extreme end, take a U-turn and make this as blank, go to the extreme left end, make this as blank, go to the extreme right end, make this as blank, go to the extreme left end, and you take a U-turn. Now friends, when you take a U-turn, you are going to get a 1. Now what is the catch over here? What is going to be 2 minus 2? 2 minus 2 is going to be 0, which in unary number system we are going to represent by epsilon, right? So now if you observe the logic which we did in this particular case where m is less than n, we converted this 1 to blank. So now if we convert this 1 to blank till you get a blank, we observe that the output of 2 minus 2 is also turning out to be blank, which should not be the case. So that means when we are actually implementing the functions, we have to make sure that 2 minus 2 output turns out to be epsilon rather than just a blank. Fine. So as of now, let's leave this case for now, and when we come across the same case in the implementation function, let's see what we can do in the transition diagram to make the things more interactive. Fine. But at least one thing is clear, that when I say 5 minus 2, the output has to be 3 zeros. When I say 2 minus 5, the output has to be all blanks. And when I say 2 minus 2, the output has to be a single epsilon. So with that thought process in mind, let's go ahead to design the implementation function or the transition diagram. So let's get started. So let's start with this. So currently we are in state Q0. In Q0 state, we realize we get a 0. So we are going to convert this 0 to blank. Therefore, let's go to the state Q1 over here. Q0 on getting a 0 is going to get it converted to blank and move to the right. Now in state Q1, we are going to bypass everything till we get a blank. So for bypassing everything, I'll be getting either a 0 over here or a 1 over here. So I'll be keeping 0 as 0 and moving to the right. I'll be keeping 1 as 1 and move to the right till we get a blank. And the moment you get a blank, you keep the blank as blank and move to the left. Therefore, in Q1 state, if you get a blank, you keep the blank as blank and move to the left and go to the state Q2, right? Now, in Q2 state, the moment you get a 0, you're going to make it as blank and move to the left. So, let it go to a new state Q3. So, we say over here, 0, make it as blank and move to the left. Now this 0 is blank and we move to the left. After that, in Q3 state, we are going to bypass all the zeros and all the ones till you get a blank. Therefore, in Q3 state, you get a 0 or you get a 1. You are going to keep the 0 as 0 and move to the left. You are going to keep the 1 as 1 and move to the left till you get a blank. And the moment you get a blank, you are going to repeat the cycle. Therefore, the moment you get a blank, you are going to keep the blank as it is and move to the right. So in Q3 state, if you get a blank, you're going to keep the blank as it is and move to the right. So you come back to state Q0. Now in Q0, again you are going to get a 0. You're going to make it as blank and go to Q1. In Q1, you are going to bypass all the zeros and ones till you get a blank. The moment you get a blank in Q1, you are going to keep it as blank and move to right and go to state Q2. In state Q2, the moment you get a 0, you are going to convert it to blank and move to the left and go to state Q3. In Q3, you are going to bypass all the zeros and ones and keep on moving to the left till you get the first blank. In Q3, the moment you get the first blank, you are going to keep it as blank and move to the right. And again, you are in state Q0. Now, in Q0, when you are going to get the first 0, as per the logic, you are going to get this 0 converted to blank and go to state Q1. In state Q1, you are getting a lot of zeros and ones which will be bypassed in Q1 itself till you get the first blank. And in Q1, when you are going to get the first blank, you are going to keep the blank as it is and move to the left. And you are now in state Q2. Now friends, in state Q2, we were expecting a 0, but unfortunately now in state Q2, we are not finding any 0 over here. That signifies that m is greater than n, and we know that when m is greater than n, where over here m's value was 5 and n's value was 2, so the answer of 5 minus 2 has to be 3 zeros, and we currently see that on the tape we are able to find just a single 1 and 2 zeros. So in Q2 state, for the first time we are not getting a 0. Instead, in Q2 state we are getting a 1. And since we want 3 zeros on the output, I say let us convert this 1 to 0 and not move the head anywhere but directly go to the final state. So that is going to make this 1 into 0 and the machine will be going to final state. So friends, over here m greater than n scenario is very well sorted. Now we are more concerned of solving the scenarios where m is equal to n and m is lesser than n. So let's consider the case. Now for considering m equal to n, I have 0 0 1 0 0 blank over here. So this will be converted to blank, this will be converted to blank, that gets converted to blank, this also gets converted to blank. And in Q3, blank on blank, we move to the right and we are currently in Q0 and holding the input as 1. Now we know that 2 minus 2 output has to be mapped to 0, right? So the output of this ideally has to be epsilon. So 1 has to be converted to epsilon in that case, and then we are supposed to go to the final state. Let's consider the same case where m is less than n also, because we have to map both the scenarios in this transition function. So we have two zeros over here, 1 followed by 5 zeros over here. So this will be blank, this will be blank, that will be mapped as blank, this will be mapped as blank, and again I come across 1 in my Q0. Now my friends, in the above scenario we see that it is the subtraction of 2 minus 2 and we are expecting the answer to be epsilon. Whereas in the lower scenario it is a case of 2 minus 5 and we are expecting the answer to be all blanks. So we have to think over here which can be implemented first in such a way that the output of the machine is going to be discrete in nature and not ambiguous. So let us say if I'm thinking of executing my third example first, in that case the moment I get a 1 over here in my Q0, what are we going to do? We can say let 1 be converted to blank and move to right. So this 1 is converted to blank, we move to the right to a state Q4, and in Q4 for all of these zeros we are going to get it converted to blank and move to the right. So this will be blank, this will be blank, this will be blank, and this continues till I get a blank, and the moment you get a blank you keep it as blank and do not move anywhere. So that completes the execution of my third example, but we are yet left with the second example. So if you observe, for the second example we say the moment you get a 1 over here you are going to get it converted to blank. So that we have done. So 1 will be converted to blank, and the moment you get a blank you are going to go to the final state. So friends, over here it is not possible to consider the case, because we see over here clearly that 1 was getting converted to blank over here, and thereafter immediately in Q4 when we are getting a blank state, that is going to final state, saying that the output of the tape is nothing, right? So this can also be considered as one of the solution, because 2 minus 2 is epsilon and epsilon is as good as an empty string. So let's not represent that on the tape itself and say that 2 minus 2 is as good as blank and 2 minus 5 is also as blank. So both of the things are acceptable over here. Fine. So that's how we have a total of 3 cases where m is greater than n, m is lesser than n, m is equal to n. Now friends, this problem, the way we have solved, could be further modified by you, considering maybe you are able to find a logic where m is lesser than n and m equal to n can also be mapped perfectly with the help of adding one additional state. Yes, you are welcome to do that, but solving it using this approach is also 100% right. So you can be rest assured that 2 minus 5 can also be converted to blank, and 2 minus 2 can also be converted on the tape as blank itself. So with this, we complete this problem. See you in the next session. Thank you.